Well, happy Tuesday! Yay, I'm excited. Alright, today we're going to talk about something called the fundamental counting principle. And it is a rule used to count the total number of possible outcomes for what we call multiple events. So that means we have more than one thing happening. We want to know how many different possible ways are there for that thing to happen. So, if our N1 is our possible outcomes of event number 1, and then N2 is the possible outcomes of event number 2, and so forth, then the fundamental counting principle says that the total number of outcomes will occur if I multiply N1 times N2 times N3 as far as it goes, as far as whatever problem you're looking at. So it's a little awkward to discuss without looking at some examples. So I think the examples will clear things up. Alright, so it says, how many different bike lock combinations are there on a 4-digit lock using the numbers 0 through 9? Now, I know I have this exact type of bike lock. It's got, the numbers 0 through 9. It's got 4 digits. You just roll the little thing. It's kind of like a blocker combination type of thing. So let's take a look at the first one. So this would be digit number 1 right here. So the first digit. All right. Now, it could be anything from 0 to 9. So how many different total numbers are there? Well, that would be 10 different total numbers. All right? Now, combination number 2. So again, you can use the numbers 0 through 9. So how many different options are there? Well, there's 10. And then for the number 3, the third number in your combination. Again, you can use any of the numbers from 0 to 9, so there's 10. And then finally our fourth digit, and again you can use the numbers 0 through 9, that's 10 different numbers. So we have all of our numbers, our N1, N2, N3, N4, 4 different events happening here, because you got 4 different little numbers on your lock. Now we're going to go back through and multiply these numbers times themselves. 10 times 10 times 10 times 10, or 10 to the 4th power, which is a 1 with 4 zeros. So there are 10,000 different ways to do a bike lock combination. Alright, let's try another one. How many different 3-letter passcodes could you create if you are not allowed to repeat any letters? So this one's a little bit trickier. Alright, so on that first digit in our passcode, this time we're using letters. So hopefully you know that there are 26 letters in the alphabet. All 26 letters could be chosen for your first digit, so that's a 26. Now, the second digit. This one's going to be careful because it says you are not allowed to repeat any letters. So let's just say, for example, you picked A for your first letter. Well, then that means when you pick your second letter, you're not allowed to pick A again. So that means now there are 25 choices left for you to select for your second digit. Let's say you select B. So when it comes to your third digit, because you cannot repeat anything, you can't use A or B again. So that means instead of 26 letters to choose from, there's only 24 letters to choose from. So knowing whether you're allowed to repeat the digits is a very important piece of information. Now, again, the fundamental counting principle says we can go through and we can multiply those numbers times each other. So I'm going to go ahead and take 26 times 25 times 24. And I got 15,600 different ways. Again, story problems always have to have at least one word in your answer, and again, the word ways is enough. That's what it's asking you. How many different 3-letter passcodes can you create? Well, there's 15,600 different passcodes, or different ways to make a passcode. So just the kind of generic word ways works for most of these. Alright, let's try one more. Johnny owns 6 pairs of pants, 7 shirts, and 4 pairs of shoes. How many different outfits can he have using one of each item? Well, I hope one of each item. Who wears 2 pairs of pants at the same time? Or 2 pairs of shoes at the same time? I mean, I guess you could maybe wear a couple of shirts, but, most of us would just put on one of these items. So let's look at the pants first. So for the pants, how many different choices does he have? Well, he's got 6 different choices on pants. When it comes to the shirts, the choices are completely different. And there are 7 of them. And then the shoes, 4 options. Multiply those numbers. So 6 times 7 times 4. I ended up with 168 different outfits. All right. Hopefully this makes some general sense. Again, this is called the fundamental counting principle. And what it's really doing is it's saving us from having to make these ridiculous factor trees, because I don't really want to make a factor tree with 168 different answers. So it would just be too huge. But again, that's why they're called the counting principle, because in reality you're supposed to write this all out like a big giant factor tree and then go back and count them, which is awful, because again, look at that, 168, 15,600. No thanks. I don't have time to write down that many different answers in a picture. So this fundamental counting principle, it's called counting principle because it's replacing all this ridiculous amounts of counting you would have to do to get up to answers like this. All right, this is what you got going on today. Let me know if you need any help. Good luck.